In this video, we discuss orthogonality of two spheres. Let us try to understand what orthogonality means. So here I have a pair of lines and the angle that these two lines make is 90. So we say that these two lines are perpendicular to each other. Now let us move to two curves. So I have got a curve C1 and I have got another curve C2. What do I mean by when I say that the two curves are perpendicular? So what does it mean that the two curves make some angle? Now here we were looking at the point of intersection of the two lines, and we looked at the angle that the two lines made. So here, if we want to talk about the angle between these two curves, we have to take help of the tangents. So angle orthogonality between curves is actually a local concept, and the concept is valid only at points of intersections. That is the kind of idea we want to carry forward from this case to any other case. So what we do is look at the tangent lines to the two curves and look at the angle between the tangent lines. So if theta is the angle between the tangent lines, we say that the curves make an angle theta. And if theta is equal to pi by 2, if the angle between the two curves is pi by 2, we say that C1 is perpendicular to C2. Alright. Now let us move to the situation of a curve and a surface. The simplest situation could be this, and the diagram depicts of what we understand, or our common understanding of a line being perpendicular to a plane. So if the equation of the line is x minus x naught upon L equal to y minus y naught upon m equal to z minus z naught upon n, and if the equation of the plane is alpha x plus beta y plus gamma z plus delta equal to 0, by the understanding that we have of a line being perpendicular to a plane, there is some relation between the direction ratios of the line and the direction ratios of the normal to the plane. Namely, they must be proportional. So L is to M is to N must be proportional to alpha, beta, gamma. Okay. All right. So if L is k times alpha, then M should be k times beta, and N should be k times gamma. All right. What about perpendicularity of two surfaces? And the simplest case again will be looking at two planes. So if I take a plane and there's another plane, when do we say that they are perpendicular to each other? So we go ahead with an idea of this kind, and what we do is look at the angle between the normals to these two planes. So suppose this plane, so suppose this is the normal to this plane, and this is normal to this plane. So let me say that this plane is pi 1 and this plane is pi 2. To pi 1 I have a normal n1, and to pi 2 I have a normal n2. Alright. If n1 is perpendicular to n2, then n1 is perpendicular to n2 if and only if phi 1 is perpendicular to pi 2. So that is the definition, that is the kind of definition we would like to give. The two planes are perpendicular if and only if the angle between the normals is 90. Now, whatever is happening at a point of intersection, exactly the same thing is happening at all the points common to the two planes. But this is not going to be the situation in general. So if I have a certain surface, and if there's another surface, and if these two are intersecting, all right, what would we mean when we say that the two surfaces, say S1 equal to 0 is orthogonal to S2 equal to 0? So now this is the situation here, and the situation here will prove to be a little different. Okay, so what we do is, so let us fix a certain point on the intersection, on the common point to the two surfaces, all right, and look at the normals to the surfaces at these 2 points. So suppose this is N1, a normal line to the surface, and this is N2, normal to the surface S2, and the two make some angle between them. If I redraw this at some other point, the angle here may be quite different from the angle over here. So this might be some theta dash. Whereas in the case of the plane, it is all the same. So what I'm trying to say is that the definition of orthogonality between surfaces is actually a local concept, all right? And therefore, when we talk about orthogonality, we have to always specify the point. So S1 is perpendicular to S2 at the point P if the angle between the normals is 90, all right? Fine. Let's come to spheres. So I have these two spheres, S1 equal to 0, S2 equal to 0. Now, the case of the two planes and the case of the two spheres are same. In the case of the plane, if the plane is orthogonal, if one plane is orthogonal to another plane at a point, it happens at all points, at all common points. Similar is the situation here. I hope it will come out from the discussion. Okay, so let us fix a point common to the two, all right? I will be obtaining a condition on the coefficients in S1 and the coefficients in S2, which comes out from orthogonality. Okay, so I wish to look at the angle between the normals to the two surfaces at that particular point. Now, what is the direction of the normal at this particular point to this particular surface? let us join the center C1 to this point P. C1P is perpendicular to the tangent plane at the point P to the surface S1. Similarly, join P and C2. C2P will be perpendicular to the tangent plane at the point P to S2 equal to 0. So C1P is in the direction normal to S1 equal to 0 at P, and C2P is a direction normal to the sphere S2 equal to 0 at P. Suppose that S1 equal to 0 and S2 equal to 0 are perpendicular to each other at this particular point. That means the angle here, that means the angle C1P and C2P is 90. Okay? Therefore, C1 C2P is a right angle triangle. C1 P C2 is right angled at P. What does this mean? So when you apply Pythagoras theorem, you get C1 C2 square to be C1P squared plus C2P squared. Now recall that writing something like this is same as writing x square plus y square plus z square plus 2u1 x plus 2v1 y plus 2w1 z plus d1 equal to 0. And similarly, we have x square plus y square plus z square and so on. So I replace this by an I and I and I equal to 1 and 2. So I equal to 1 gives me this, I equal to 2 gives me this. Okay. What is C1, C2? Okay, so with this, the coordinates of the center are, and the coordinates here, coordinates of the center in this case, all right, and the radius, the C1P is the radius, let me call it as R1, C2P is the radius, let me call it as R2, all right, where what will be Ri squared? Ri squared is U1 squared Ui squared plus Vi squared plus Wi squared minus Di, all right. So let me put that information over here. So C1 C2 squared, I'm going to use the distance formula. So minus U2 plus U1 squared plus minus V2 plus V1 squared plus minus W2 plus W1 squared will be equal to C1P squared, which is R1 squared, that means U1 squared plus V1 squared plus W1 squared minus D1 plus U2 squared plus V2 squared plus W2 squared minus D2. Okay. So let us expand these brackets, and you will notice that U1 squared will cancel with this, U1 squared, U2 squared will cancel with this. So all the squared terms get cancelled, all right. So we are left with minus 2 U1 U2 from here, minus 2 V1 V2 minus 2 W1 W2 equal to minus D1 minus D2. which means u1 u2 plus v1 v2 plus w1 w2 is equal to d1 plus d2 upon 2. Right? So this is the condition for the orthogonality of the two spheres S1 equal to 0 and S2 equal to 0. In the previous video, I had mentioned about this coming from the coefficient of some, coefficient of lambda in a certain quadratic of lambda. So there one was looking at the radius of a sphere coming from a family of spheres, and the requirement that the radius squared should be greater than or equal to 0 was related to a certain quadratic, and this quantity, so you can put, you can so what was that quantity? That quantity was simply twice of u1 u2 plus v1 v2 plus w1 w2 minus d1 plus d2. All right, so that was the quantity which had appeared there. Okay, and my remark at that time was the coefficient of lambda is somewhat interesting, and that's how if the coefficient is equal to 0, it says that the two spheres are orthogonal to each other. Now, that is the point I wanted to make. Okay, so this is the last video on spheres. Some students had requested to give them a PDF of the assignment. So what I'm planning to do is, from the assignment which has been given to you, I will choose some problems and make a video and show it to you, as well as provide you with the PDF version. Thank you.